3 revolutions or 3 turns. This was on the video from last week. Then they asked you over here, well, what happens when we have, if 360 degrees equals 2 pi rads, 1 revolution is 2 pi's, I agree. How many rads, not pi rads, but rads, did the wheel make in 6 seconds? Well, in 6 seconds, my wheel made 3 revolutions. 1, 2, 3. So it ended up being 6 pi's. 1 pi, 2, 3, 4, 5, 6. So how many rads did it make? 6 times pi is actually 18.85. I don't know what I was doing there. So what was the angular displacement? The word angular displacement is, what is the distance that it traveled? 18.85 rads. Because it rotated 3 times in 6 seconds, which is 6 pi's. And 6 times 3.14 is 18.85 rads. So please make that change. I apologize on that part. Somebody mentioned, I'll say, oh, I better make sure I tell everybody. Then, last week, homework 1 was pretty easy cheesy, angular displacement. The word angular displacement is the distance that an object travels around the circumference of a circle, okay? And the angular displacement is going to be in rads or radians. And that was pretty much the gist of their lab. Hint, hint, quick reminder, don't forget positive and negative. Like last semester, forward was positive and backwards was negative. To the right was positive and left was negative. We have positive and negatives here. Then we started on this page over here where we did our math. Jade, I'm going to cheat off of you. What's the answer here? Anybody disagree? We all agree? Melody, what'd you get for the second example? We were looking for the theta, so we did have to rearrange it. What'd you get? How many rads? Page 2 in our notes, or page 4 in our notes on the second example. 12.5 rads. Thank you, ma'am. Courtney, what'd you get on number 3 about little Johnny?
I got 170.8 meters.
178?
170.8.
Thank you. Sorry. All right, and then the next one says here that there's a new planet. It was discovered orbiting the moon of Earth. Okay. Wow. If someone at the equator of this planet traveled an arc length of, which is my S, and it has an angular displacement, my theta, of 6.28 rads, which is 1 full circle, what is the radius of this planet? Question mark R. Okay. So in this case, we're going to go ahead and use the same angular displacement. We were just going to rearrange it to R equals S over theta. S was 63.69. Theta is 6.28. And I didn't do my homework on this. Divided by 6.28. 10.14 meters for the radius. Okay. Now, let's talk about frequency and period. And I know I videoed it, but you stop me if there's a definition or something that you're like, well, wait a minute, explain again. Now, I like to stop here because I know right now we're not going to make it to 4 units, like maybe 5 units. And traditionally we would make it to waves, and we would need to know this for later on. But to be honest, I'm going to be honest with you, we're not going to make it that far this school year, which is fine. But here's what I do need to tell you. Those 2 equations are not on the formula chart, okay? There are a couple of equations that are not on the formula chart. Those 2 are not. They're not on. But to be honest though, they're not even helpful. Because every single time I do an equation for some crazy reason, other than, I don't know, they want to be mean, there's never a frequency and there's never a period there. So either way, those 2 equations aren't even helpful. Here's what you do need to memorize. If I was you, when I'm about to take the test, I would probably pause for a moment and do a little bit of brain dumping. And I would just go write on the piece of paper or on my test real quick a few things. One thing I would probably write would be clockwise, negative, counterclockwise, positive. Okay? Another thing I would write on my test, capital T equals the time over turns. This is the equation that you need to know. Those two first things are not even on there. Those are the official equations. This one's like a made-up equation by the definition of period. The definition for period is the time it takes for one full revolution. So a revolution of a week is 7 days. That's 7 days. Then we start all over again. Right? The time it takes for one full revolution in a year, 365 days. And then we start all over again. Okay? Now, once you do have the period, then you can do the inverse over here, 1 over t, to get the frequency. So hopefully, not too bad. Frequency's definition is the number of revolutions or turns per second. Okay? Then, we did this one earlier today, so here's the problems. We did one practice problem, then there's another one I didn't do on there, so double check if you've already done it. The haunted Ferris wheel that Samuel's riding, rotates 20 times in 10 seconds. Again, no frequency and no period for me to find the period. So the amount of time, 10 seconds, divided by the turns, 20, equal 0.5 seconds. So double check your answer if you've already done it. If not, then write it in. Now the frequency, which is the inverse, is 1 over t, or 1 over 0.5, which equals 2 hertz. You've seen that before. Well, I don't know, maybe you haven't. The back of your microwave has how many hertz? Your cell phone runs on hertz. Your TV, the remote runs on hertz. It's all about the hertz, the frequency. Okay? Now here's where I want to make sure I stop and go over and explain, and I'm going to explain this probably like 4 or 5 times. You're going to be sick and tired, but it's such a concept that's going to be quizzed and tested that people always get wrong. So let me go through here first. Since it's difficult to describe the motion of an object moving in a circle compared to linear, which is like what we did last semester in a straight line, circular motion is described in terms of angles, but we do not use degrees, we use rads. We know what a rad is now, through which the object moves or rotates. Remember, we can do this based on the experiment that we did with our radians or paper plate. Now, the distance moved around the circumference of the circle compared to the length of the radius is always going to be a certain degree. Now, I've done this is my 13th year, 14th year teaching. I'm running out of years. But the correct answer for no matter what circle is 1 radian is always 57.3 degrees. 1 radian is always 57.3. Did I go to the decimal point? That's in your notes. We left that blank. All right, we needed to fill that in. That's why I have a little sticky tab here. No, I didn't go to the decimal point whatever. Look at this. 58, 57, 59. Pretty close. Let's look at this one. This one's make believe. This is wrong. 65, 62, 57. 57 though, that's pretty close. I mean, 58, 57, 58. 57.3, pretty darn freaking close again. 57.3, 57.3, I just made up those numbers, I didn't do it. But 57.3 is the degrees of 1 radian. And the reason why I'm saying this so many times is because I can't recall last year's, because all of this stuff happened and it was a hot mess right after this unit last year. So I don't remember exactly what happened. But I recall the test the year before that, and the year before that, and the year before that, that was always a test question. Did I pull it off last year's test? I don't think I did. If I had to bet money, I would bet that that's a test question. What is the exact degrees of 1 radian? 57.3 degrees. That's the reason why I'm stopping to go over that. Now let's keep going, because I left that blank when we did that together on the video. Now, let's talk about the word tangent. You probably had an amazing geometry teacher. And your geometry teacher probably went over the definition or the word tangent, okay? Now, tangent is a straight line that touches the edge of the circle but does not intersect the circle. So for an example, I'm gonna go over here to this circle. If we're talking about a dot right here, and they tell me that my circle is moving counterclockwise, which would be this direction, okay? What would be the tangent line here? That would be the tangent line. Now in math class, you would draw it full. You would go all the way over here. But in physics, we kind of just use this part of the line. Now why is that? And I really want to kind of go over the definition and meaning of it. Okay? So let's go back and let's just, for a moment, visualize a yo-yo on a string. It's an old yo-yo, old string, and it was like in my garage, rotting away. Okay, but as I'm over here playing, because you've probably seen people, in your umpteen years of, living, some crazy, right, sibling or somebody at home has something on a string and is spinning it. And if I was to be spinning it right here, you'd be like, whoa, hold up, I don't need that sucker flinging off and hitting me in the head. Well, if it flies off, let's go back to my yo-yo. I'm seeing this direction, and I'm holding it this way, and that sucker's going around and around and around. And you're just like, every time it comes this way, you're like, whoa. Because if it breaks loose, which all of a sudden I'm doing it, the yo-yo on the string, and it breaks loose and it flies off in this direction, it flies off in a straight line due to Newton's first law of motion. An object in motion is going to continue in motion in a straight line. Okay? So that straight line is called the tangent line. This equation is used to find out how fast it's going to shoot off. So if somebody had that yo-yo or something on a string and they're just holding it around and flinging, and it's about to fly off and hit somebody, how fast is it going to hit me in the head? That's what this equation is for, okay? So why is it moving though, or why is it, let me go to another example now. I think I said this one last week. You're driving in a car, whether you're the driver or passenger. Passenger is probably a little bit better. And somebody takes a sharp turn and they're moving fast. And when they turn left, your body moves to the right. Your body was moving in the tangent line. Did you fly out of the car? No. Why not? Because the door held you in. The door of the car was the centrifugal force that kept you in. If the door wasn't there, you would have flew out of the car in a straight line due to Newton's first law of motion. Okay? Now, could we calculate how fast you're going to fly out? We could, and that's what those equations are for. Okay? So, the concept is a test question or a quiz question, and many students miss it. So, I want to show you here, or this example. So, I don't know if anybody went to this little video to go watch it or not. I'm lazy, I should have pulled it up. But there's this fire spinner. And so he has this ball of fire, and he starts spinning it. And I don't know, he had like a hula hoop or something, but it's a ball of fire first. What happens? The fire's just there. But as he continues to spin it faster, 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 the little sparks are shooting off. Okay? Trevor, why are the sparks flying off? Because that's going to be like similar to the quiz/test question. Okay, it might be a picture and it might be a video. I think I'm going to try to put it on a video. Now, look, I'm even telling y'all how this year, since it's going to be, on Blackboard, I think I'm going to do it on the quiz and do a video of it. If you see a video of something like that, a picture, the little sparks are flying off. Why are they flying off? Is the question. What's your answer?
Because it's spinning and it's just throwing it off as it's spinning.
Say it again.
Because it's spinning and it's throwing it off as it's spinning.
Okay. Why are they getting thrown out as it's spinning?
Because of
Because because something's missing. Something
holding it in.
Say it again. Something holding it in. There you go. Now that's what I'm looking for come quiz test day. So let me go back. So he said I said something's missing. He said something holding it in. Absolutely. So now I'm gonna I'm skipping through our notes a little bit to centrifugal force. In our notes, just like we had last school semester, we had we had applied force, we had frictional force, we had tension force, we had different types of forces. Now, same thing here though. Let's go back real quick to our car. When you're in the car and you're the passenger, and somebody turns and you kind of, sway and move this way towards the door was the applied force holding you in so you don't fly out. Let's go back to the yo-yo. I'm holding the yo-yo right here and I'm flinging this sucker as fast as I can. What if I let go with the string? Sucker's gonna go off. But the string is the tension force holding the yo-yo in a circle. There's no force holding those little sparks of the fire, so they're flinging off in a tangent line, okay? So one more time, your answer needs to be something like, there is no force holding it in. Something like that needs to be there, because if not, then it's not gonna be marked right. There's a force missing that's not holding it in. And because it's not holding it in, it's gonna move in a straight line, which is a tangent line, due to Newton's first law of motion. I mean, the question might be, well, how does the object move? It moves in a tangent line. Why does it move in the tangent line might be a question. Due to Newton's first law of motion, an object in motion is going to stay in motion. So any parts of those may be asked. We want to make sure we understand the whole concept of that. Then, there's more than one equation. We had speed and velocity, and they're the same easy equation. But here, and they're not too bad and difficult, there are 3 different equations depending on what variable they gave you. So more than one way to find the speed or the velocity. One more time, speed or the velocity. Okay? And again, they're used interchangeable. Then we had a couple more practice problems. I think will probably be perfectly good. Centrifugal acceleration. Okay? So I need to go over this because this is a big section of our quiz questions and I don't want us to miss it. So centrifugal acceleration is really just like regular acceleration. We have an initial velocity, a final velocity, find the difference divided by time. We have velocity squared divided by r for radius here. There's actually another acceleration equation, but I was like, oh, let's just toss that one out because that one's a little bit harder. So for us this semester, we're only going to have one centrifugal acceleration. V squared, and I forget to square the V. Or if I'm trying to search for the V, don't forget to square root that if you're looking for the V. Divided by R, okay? Again, make sure your R is in meters, not kilometers, because those two are in meters. Everything needs to be the same. Now I'm going to come back to this in a moment. We need to keep going. Centrifugal force. Like I had mentioned earlier, if there is no force holding it in, centrifugal force is a force required to keep an object moving in a circular path, then it's going to fly off in a straight line that we call a tangent line, okay? Why? Because of Newton's first law of motion. But F equals ma, look at that, same exact equation from last semester. F equals ma, we just put a little c because it's circular. So you're going to use the circular acceleration equation and multiply by the mass in kilograms, not grams. Okay? But here, that's where I always get a lot of students missing these questions. Like missing them bad too. I'm like, they're not even math questions. I miss them. So I'm going to go over this. Centrifugal, or some people call it centripetal, versus centrifugal. Centrifugal means towards the center or center seeking. Centrifugal means away from the center, center fleeing. So what I need us to know is any word that has centrifugal acceleration, centrifugal force, centrifugal whatever, it's going to move in. Centrifugal force, centrifugal acceleration, centrifugal whatever, it moves out. But, here's the but, if they use the word velocity by itself or tangential velocity, then it is a straight line when it shoots off. So let me go ahead and try to help you out. I want to explain it. So I'm going to come over here to this circle. Quiz day, like I'm giving you guarantee. This is what it's going to look like. Test day. We're going to have different locations. So this is going to be location A, location B, and location C. Now, the question is going to tell you that the object's moving counterclockwise. So it's moving in this direction. And they're going to use counterclockwise, so you need to know the difference. Okay? Counterclockwise. Let me put it here. Counterclockwise. So I know it's moving in that direction. And then they're going to tell me, at location A, your answer choices are A, B, C, D, E, F. Which vector arrow would match the centrifugal force at location A? Which vector arrow will match the centrifugal force at location A?
D.
Say it again.
D.
Nope.
Okay.
It would be E. Centrifugal force. Be pointed out. But if they asked you about the velocity, then it would be D at location A. Now they use the word velocity sometimes, and sometimes they might use tangible velocity. And that's what's confusing, because it's velocity. It's like, well, what do you, they're talking, the word velocity means tangible velocity. For an example, a location, B, what would the centrifugal acceleration be at location B? A, B, C, D, E, F. So centrifugal acceleration would be D also. So D could be used here and here. Make sense? All right? Now this line, which is D, represents centrifugal acceleration. This line, which is D, for location A, represents tangible velocity. Okay? And it just becomes, it is kind of confusing, and so I just kind of want to explain and go over it. So this, for an example, would be centrifugal acceleration for that arrow. And even though they're the same arrow, both of them are D, they mean two different things. Okay? Centrifugal acceleration and tangible velocity. Centrifugal force for location A. So you're going to be given A, B, C, D, E, F, G, or whatever for the arrows. I'm just tossing it out there. Okay? That's going to look like 8 questions on the quiz, 6 questions, and there's no math on that. It's just arrows. Okay? But it's just those definition words. Okay? So I really like to go over those with all my classes, just to make sure that we're all on the same page when it comes to quiz and test day. Because I know that's like 6 to 8 questions on the quiz. Alrighty. Now the next page that we were at, we left off right here. All of this pretty much talks about an object that's moving in a circular motion has to have a force that keeps it in. If not, it's going to fly out in a tangent line due to Newton's first law of inertia, and it's going to move straight out. So what I just said over and over and over is right here. That's all that is. And then the last part is just kind of like a comparison for you. And I thought this would be nice. I actually added that in because look at all those variables that we're talking about this unit. Capital T, lowercase s, lowercase t versus capital T, and this omega sign and the theta sign. And so that's the reason why I added that in, just to kind of help you out a little bit. That is all the notes. I've talked through, yes, the video, but I wanted to personally talk through you with the notes and explain that. Now I'm going to move that out the way. Is there anything in the notes that I missed? Because I wanted to go through those ones that I did leave blank. The next thing is homework number 2. And homework 2, yes, it's 2 pages, but again, it's not a lot. But look at that. Very similar to the quiz. And we just talked about it. So now I think everyone should have no problem now. Okay, so looking at question number 1, so if you've already submitted it and that sucker's all wrong, and now it makes more sense, no problem. Okay, I'm not worried about your correctness, now you know what's right. It says here that it's moving clockwise. So clockwise is gonna look like this direction. Okay, promise you quiz, I promise you test. It tells you here, which vector below represents the direction of the velocity vector? That's the word they used here. Same thing as tangential velocity, okay? For location B, okay, if it was moving in this line and it broke away, it would shoot like this in a straight line due to Newton's law. So correct answer would be D. Makes sense? Hopefully, and I don't know if it made sense before this, hopefully it's like, this is easy. The same thing over here we did on homework 1, clockwise, counterclockwise. So counterclockwise, clockwise, counterclockwise, forgive me. Assumption, right? If there's no negative, no positive, it's considered to be counterclockwise. All right, go ahead. You're going to use the same equation, omega equals theta over lowercase t for all of those. Turn the page. Man, we're doing that faster than we did earlier today. Andy's a passenger on an amusement park. It says here she's sitting on the ride 3 meters from the center, which is the radius. If the ride makes 10 revolutions, turns, in 4 seconds time, what is Andy's tangential velocity? Question mark V sub t. Okay, the problem here though is that they didn't give us our period, and this time I have students use this as the period time, and that's not correct. So step 1 is to do this equation. Step 2 would be to do this equation, 2 pi r over capital T. Okay, so it's a 2-step problem. Number 5 is also the same way, a 2-step problem. I just want to make sure I kind of set up with you. And then number 6, look at that. Just like on the front page, just like what we talked about in the notes. So hopefully it's easy. You have no problem answering that. Other than that, I've got to do something for Miss Wadding real quick. Is there any questions that I can answer for y'all? Because if there is, you let me know. All right, make sure you leave your lab papers up out there on the table. So Miss Wadding, traditionally we pick up your calculators at the end of the semester. Check them back out when the semester starts again.